Hi, everybody. So, how's your Chinese New Year coming? Yeah. Um, yep, today we don't have any physical lecture. We'll have this online instead. So, this morning we already have. So wish you guys a Chinese New Year. Uh, this is my Chinese New Year 4春. Yeah. Hope you guys have no bugs, whatever in your program. This morning, we already have two lab sessions. The lab session already recorded and put inside our so-called our cosmology video. Okay, so if you haven't joined the session, please go and have a look. The important thing is we talked about quite a lot of C purpose and uh, pointers stuff there also. The other very important information is we have talked about the so-called assignment. Okay, it's very important. And as I said, a lot of you may be having difficulties using pointers, and the tradition uh, problem of this course is a lot of students will find assignment 3, 4, 5 very difficult, especially 3 and 4. So assignment 1 and 2 are designed for you to go slowly. Please, 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 please do assignment 1 by yourself. Okay, repeat, please do assignment 1 by yourself. Okay, uh, if you cannot do assignment 1, it is quite difficult for you to proceed the course. You may deem yourself you cannot get B plus and above. Okay, so please do assignment 1 yourself. Okay, today we'll start. We'll talk about an easy one first as we start our Chinese New Year. So we talk about ADT. And we talk about some of C purpose structure and filling the rest. Okay. How come I cannot hide this window? Okay. Yeah. So we talk about ADT. ADT stand for abstract data type. It's a concept. You can say that this concept is a bit non-programmable, but let's talk about what it is. Okay. Let's start. Let's say in the middle of the night, you are hungry. What will you get some food to eat? How or what? What will you do? Well, if you are in the dorm, you are in your hostel, maybe you just order some food, right? But what if, let's say, you are at home? We may just go into the fridge and see whatever is in your fridge, and whatever there, you try to cook it. Okay. Maybe you have some bread left to make some sandwich. Maybe you have some instant noodle, you make some instant noodle, and then you see whether you have something add on it, maybe a ham or egg or hot dog, whatever. Okay. So you basically cooked depending on what ingredient you have. So, however, usually you expect you have some very nice meal, but somehow you actually reality you didn't cook very well because you need to depend on what you had, and maybe you are not even familiar with this. However, what will the hotel's chefs cook? Can they do the same? For example, let's say we have this Chinese New Year coming or the Christmas coming. How will the hotel decide what is on their menu on these important days? What is the design process? For example, in Christmas, they want this turkey. In Chinese New Year, we want this, I don't know, seafood or whatsoever. Okay. They will actually first find the recipe, design the recipe. Then they actually decide what are the ingredients, and then they cook. Okay. Do you see the order of difference? And one more thing is usually maybe not only the chef design the menu. Usually it's the manager or even the business people or the management office to design the menu. Why is it relevant to our data structure algorithm? Because then what is the outcome first? They want what is the event. Maybe it's a Christmas dinner. They want to create a very Christmas celebration. Maybe it's Chinese New Year. They want to create a Chinese New Year menu that is blessings or making people think they're prosperous or something. How we cook is we just see whatever what we had. Okay, then we try to cook. So designing what is the outcome first is actually what really the customer will get. And actually how we really cooked, how we actually do it is called the implementation. I would like you to actually think about these two big outcomes are different. For example, if you talk about a car, you sit in the driver's seat, you are actually manipulating the steering wheel, maybe the gear, maybe stepping on the pedal for acceleration. That is actually your interface. How do your car works? What is the implementation of the car? You have no idea. Maybe you know a bit, but you don't have to know about it. And also one thing is, from time to time, you don't care how exactly it's implemented. You don't even care, is it an EV or is it a petrol car? They doesn't matter that much. The interface will be the same. So we would like to use this concept in our data structure. One is called the interface or the behavior. How the others use your data structure. If you remember our linked list, we define all the function header and we actually encapsulate all the other like data member or the implementation. That is actually what other, remember last time we talked about how people use your linked list. That's actually your interface. The implementation details is how do you really implement it? For example, do you do a linked list? How do you manipulate the pointer? That is the implementation. I would like you from now on think more about you should separate it. Okay. For example, if you talk about there was one data type similar to linked list, I would like to insert a pair of key and value structure. What is key and value? This is actually a very standard symbol table, or we call it dictionary. For those people maybe using Python, you know what is it. Key and value is a very normal database format. For example, for your student record, you have all the information about you, your name, your record, your address, your academic result. But when we search for your record, we need a key. So the key can be your student number. So you actually insert this pair of data into a big database, and then you can, of course, search it, delete it. But that is actually the upper part is called the behavior or your interface. That means if actually I really have this data structure, maybe it's a class, maybe it's something else, how are you going to interact with my data structure? Through these functions. It should be like if you implement a class, it should be your member functions. However, what is your internal storage? Are you going to store all your student record in a linked list or hash table or trees or whatsoever, put it in a file, put it on the cloud? That is actually your implementation. They can be different from time to time. So we would like you to think about what is the specification and what is the implementation of every data structure. Simply just like your normal data structure you're using, like integer or strings, they have all this type of separation. For example, you can see that C++, Java, Python, they all have this common data structure like integer. They can also do addition. They can also do multiplication. Those are their behavior and interface. However, underneath, how do they implement is another issue. Just to illustrate this idea, maybe I'll mention this interesting story. In 1970, I'm not 90, in 1770, how many years ago? Almost 200 or 300 years ago. In Hungary, there's actually have this person invented a machine that can play the game of chess. And even more seriously, this gaming chess, this machine already can defeat most of the opponent around the Europe, including Napoleon, this whatever, Benjamin Franklin, whatever. Okay, how can they have such an advanced AI at 1770, 200 years ago? It turns out that this is a flaw. So actually is one man hiding within the machine to play the chess. So the secret is only revealed after almost 100 years in 1850. But what? So anyway, at the end of the day, we have this so-called this land called Turk machine is actually talking about how people cheat people. But this mechanical Turk is a good example of specification and implementation. Specification is how you play the chess on the top, the red circle, which means that is your interface with your real world, how you interact with the machine. But how do you implement the machine? In this case, it's a real person. You put a real life living person inside the machine. Or, of course, in nowadays, we can actually implement the real machineries. We can really use real AI to implement this. So back to our data structure, whenever we have a data structure, we can define what is its abstract data types in two ways about the specification. So, for example, how do you implement a stack? A stack is a very, very simple interface that you just push and pop. So a stack is like as in like the normal bucket. You can only stack is only storing the element as in something like vertical. And for example, in this stack, I already have 4 numbers, the 45, 57, and so on. When you want to input a new item into the stack, let's say I want to add 77, what can I do? I can only put it on top. That's the only way you can access the data structure. And if you push some more, you can only put it on top. So you are stacking things upwards. How do you get item from the stack? You pop. But when you pop, you can also only access the top one. For example, 33. When you remove 33, the 33 is out of the stack. And you can only access that. And the next one you can only access is the next top of the stack. So this mechanism is the stack mechanism called last in, first out. The last one who being pushed on the stack is the first one you can get out. Okay. So you can keep popping and popping the stack. Yeah. So of course the error is what if you want to pop the stack when there's nothing. So this one is next thing that we don't know about that. You can actually have another function called empty that check whether the stack is empty or not. But there is a specification. The question now is, how do you implement it? Okay. For we actually if you into so the time preventing you can actually use an array or use other things. But let's see, how do we use a stack? This is called a template. A template will be introduced in the next tutorial. Simply means a template can be implemented as any different internal data value. What does that mean? Remember last week we talked about linked list that only can store integer. So what if we can actually have, we also actually we want to store strings. We also actually want to store a linked list of other things. So we do not write a duplicated data structure for that. Instead, in C++, you can do this. Before you implement your data structure, you can actually say that is a class T. And when you define a class, you can actually so-called re-implement your list as list T. So this list T is actually a linked list. Okay, this will be introduced in the next tutorial in week 4. How do we use the template to introduce that? But basically, this is a linked list we talked about last week, but instead of integer, it can be any class. Any data type. And that is all. That's all. We can actually define a generic stack for every different data type. Of course, when you push something on the link or the linked list, you can actually use push and pop. Okay, so yes, I think my network, I don't know why it's not that stable. Yeah. So for this one, of course, when you put something onto the stack, is the data type T. If you pop something, it's returning the data type T. For example, if I want to repeat the last integer linked list of my class, I can actually make a linked list of integer. Okay, so how do we push something onto my stack? I can just insert head. That is inserting an item on the top of the link, the head of the linked list. How about pop? Pop is removing something from the linked list. You can remove head, but before remove head, you need to return the item. And you check what is the head item in the linked list to return the item before you remove it. So this is actually very simple. If you talk about, go back to this one, you can actually think of this as actually a linked list. So the linked list head, this is the linked list. The head pointer is actually pointing to this one, and each of them is pointing to the other one. And the last one point to a null. A null, sometimes we can use the symbol as a ground. So it is actually a linked list. Okay. But of course, this is only one of the implementation. You should be able to implement the linked list with other implementation, like a array whatsoever. But that was exactly the separation between the abstract data type as in implementation. Of course, other than stack, the other popular one is actually the queue. The queue is a bit different from linked list. It's first in, last out. Queue is a normal queue, right? I hope you guys all know what is a queue. For example, queue is like you queue in a restaurant or you queue in a bus station. You have a front of the queue and you have the back of the queue. You can enqueue something. That means some new items is putting into the queue. But of course, if you're following the order, the new item has to go to the back of the queue. And the queue means you're being served or processed. For example, if it's a bank queue or is it a restaurant queue, that means the first one here will be removed from the queue and being processed. So it's the queue. So when you enqueue, you have to give it items, but if it's the queue, you have to remove the item. So how do we actually implement it? So that is for you to think about, okay? You can actually try to work with this with your assignment 1 and 2 and see whether you can form a queue data structure. Just a question. You can actually try to answer in the chat. Which data structure do you think is the most used in our practice? Any idea? Most of you select stack. Well, I think, yeah, stack actually is the most often used, especially in your function stack. Uh, uh, Even your recursion, all of these are using stack. But of course, list is the next one, I would say. Queue is more for, well, we will use that. At least in this in this class, we also will use that. For example, breakfast search is using queue. Yeah, dragon. I like dragon. For example, we have a list. A list is not our list, it's a normal list. A normal list you can actually append and prepend and put all this, which is like an intermediate structure of stack and queue. But think about if I want a list that require this ADT, that means I want your list can do the following. how are you going to implement this? So can you have a feel of this? So the abstract data type is like, I want to design a data structure. And what I can do, I list it out for you. For example, this list have this function. I can append, prepend, and so on. Then you have to decide what is the implementation. Okay. The next thing is related to C++. It's called inheritance, which is a very powerful so-called, I think it's one of the most powerful invention of the OOP. Let's say I already have a stack. What if I want to build another variation of my stack, which is a better one? Maybe a lot of time I need to add more new functionality, or maybe improve efficiency, or do some other interesting things. For example, let's have a very nonsense functionality. I want my stack, when you push an item to a stack, I play a sound B, and then I want to push something, and then I play a sound do. Okay, so it's called a B do stack. So that this is very annoying stack. It's called B do, we do, we do, we do. How do we implement this? The solutions, wait a minute, we already have a stack. Do you implement this B do stack from scratch? Or do you modify the original one? Or do you copy the original one to a new one and modify it? Which one do you think you prefer? A, B, or C? This is an opinion question, not a factual question. There's no correct answer. What do you think? Some of you think one, some of you B, C, okay? Good thinking, but I'm sorry to say that all of them have their disadvantage. It's not that because your thinking is wrong. It's in the beginning, we don't have the functionality of inheritance. You have to be forced to do one of this. What is the problem of the first one? If you implement from scratch, the first disadvantage is you wasted your effort. Your effort to implement the original stack. Secondly, when you develop it from scratch, you may encounter the same bugs, whatever that you already debugged in the first stack. So this one is wasteful. If you modify the original class, maybe it's clever, a bit more clever. But what if I want the original stack, which is having no B2? I don't want to annoy people. You destroy the original stack. Of course, this one seems like the most appropriate one. Now you have two stacks. One is the original stack. One is your B2 stack. Okay, now somebody discover a bug in original stack. What happened? Maybe somebody have another way to so-called improve the original stack. What happened? You have to go to the new B2 stack. Maybe you have to debug the same bug again, or you need to go to find out what is there in the B2 stack. And what if you have other BB to do stack or whatsoever, you have a very super stack that is also similar to the original stack. And you use this copy and paste code method. Then when you have something you figure out, you want to say, oh, I need to change the original stack, you have to go and find all the other stack to correct it, which is totally not making sense at all. So I'm not saying that you guys are wrong, because that is actually the purpose of doing this inheritance. For example, so this just again, what happened is I will use this is called, if I want to build a B2 stack, I will so-called use inheritance. So B2 stack is a subclass of the stack. The original stack is the parent. So you can imagine it's like our biological parent. What will you get from your parents? It may not be pleasant to everybody, but you will get your biologically some of your feature of your parents. Maybe your appearance, maybe your intelligence, maybe let's don't talk about the non-physical stuff first. Maybe your hair color, maybe your eyes color, maybe your height. Okay, so you actually copy some of things from your parents. This is exactly the concept. See here, the first line is the template that I can cater for any data type that is not related to inheritance. So now here, I want to construct a new class called bboost. Oh, sorry, here is using bboo. Doesn't matter, bboo or b2, both are annoying. I want to construct a new class called bboost stack. Look at this. What is this? This is the inheritance part. What does that mean? It means the bboost stack is going to inherit from the stack, in which this public means I'm going to inherit everything public from there, which become public. What does this mean? This basically means my new bboost stack can have all the public features of the stack. Of course, it actually did inherit all the private member, but just cannot access inside. Later, we'll talk about that, okay? But this only one single line basically is the copy and paste process without real copy and paste. However, you want to modify your stack, right? You want to modify your stack to become more powerful. How? You override your parents. That means originally without this one, you already have the function push and pop from your parents. But now I want to override it. So again, without this one, your bboost stack already copy all your parents' ability. But now I want to make it even more powerful by redefining it. How do I do that? I redefined here. Anyway, I redefined the push and pop here. Look at this. This bboost stack, I redefine the push. But what should I do? When I push, I say B like that. And then I will actually put the items into my stack. Do I re-implement the functionality? No need, because I can call my parent way of pushing. This one will actually go to find your parent's code and use it there. So now your new push for your bboost stack actually have the new functionality of playing a B, but then you will still use your parents' way to push it. What is the advantage? You modify and add new power, but this point is a very powerful point because you reuse your parents' one. Any bugs there, anything to change, you can actually just change one place in parent. Same as a pop, you only play a boo, and then now you use your parents' pop. Then it's very simple. Then that is the complete implementation of bboost stack. Okay. So for example, this one is a demonstration that my stack can be any data type other than integer. I created in a class called food. The food have calories and the so-called the food types. So you can see that doesn't matter what is it. Actually, when I push the food, push 4 times, the stack here will say 4 times B, 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 B. And then when I pop this stack here, I will say boo, and then print out what is the food. The food is the ice cream. And then if I push it again, you B again. Okay. So of course, this bboo is not very useful, but it's a demonstration of how do you enhance your data structure by just inheritance. Okay. And the next one is polymorphism. I think in this class, probably we won't use it. Polymorphism is a very tricky one. That is so powerful that a lot of real software engineering needs it. Probably you'll get more hang of it in your CS2040, but I just introduce it here. So now polymorphism have to be deal with pointer, okay? The following 10 minutes may be the most mysterious 10 minutes in your life. This is a stack integer pointer. This is a bbool stack. In C++, you can use this stack pointer to point in the bbool stack. Do you see that? This is a stack pointer. This is a bbool stack. Now, if I say S push, will I call the bbool stack push or will I call the stack push? There are difference. The bbool stack will beep, but the stack will go silence. Which one? Any guessing? Will it do a B or not a B? Anyone say no B? Anyone say B? The answer for this question is it will not say the B because the pointer is the stack. However, it is not desirable because it's not you supposed to do because the bbool stack itself is the bbool stack. You're calling it to access its real data. So what it does is you can add this virtual. When you do virtual, the simple thing what you do is when you do virtual, when you call the pointers from the stack, look at here. This is a stack pointer, but you point to a bbool stack. You call the push, you will actually call the push from bbool stack because it's a virtual pointer and the C++ will look for the correct push operation during the flight. This one is powerful in real development, but I would say I just introduce it because probably is not very easy for beginners. Okay. Yeah. For example, this is another example. I have a class called animal, and the animal can talk. But animal, because it's a generic animal, it will say just nothing. And the dog is inherited from the animal, and the dog will say wolf. And the cat is inherited from the animal, and the cat will say meow. So in here, the dolly is a dog, an animal, but it's actually a dog. The orange is an animal, but actually it's a cat. I can just directly say dolly talk, orange talk. After that, this one you have wolf and meow because the virtual pointer will be able to find the correct one. I don't know whether you can actually so-called appreciate this. Why? Because you may create a big game. The game has a lot of animals, and you can create different animal on the fly. Maybe I don't know, you're doing what game? Animal Crossings, Roblox or Minecraft. So all the basic blocks is one type, but you can create all the different type because of the users. And whatever it is, you can use display and manipulation depending on your creation, on the real-time running. So this is an extremely powerful techniques for the virtual pointer. It's called polymorphism. Okay. So for example, there's another example that what if your parent class is a shape? The shape have the so-called the function of like calculating area or doing all this drawing on screen stuff, but you can create all the subclass of different shapes like a circle, triangle, rectangle, and when you call the calculate areas, it can depend on which specific shape you can actually do different calculation. Okay, yeah. The last thing I think last class that people ask, what if I in the children, what is the problem of what is the purpose of private, protected, and public? Okay, so here, for example, if I want you to do the bbool stack and I try to access the linked list, it will have a compilation error. Why? But I think I inherit from my parents. I have everything. No. In your parent class stack, the linked list is being declared as private. I'm sorry to say that if you inherit from your parent, you can only inherit his public members' data attributes or functions. not anything private. Okay, does it make sense? Your parents' private property is not your property. Then how? In inheritance, we'll do the following things. Instead of using private, we use protected. Protected is still like private. That means other than your own class, outside class cannot access it. They can only access private. But protected means your children or your subclass can still access it. So usually for convenience, we'll be using more protected if you are getting ready for some other class to inherit your class. You only use private if you really want to limit your data functions or attributes only to your class, even you don't let your children access. Okay, so that is a difference in that. Okay, so that is our first section. It's not directly still related to uh, our algorithm yet, but it's related because we're going to use all this later in our assignment for generate data type, inheritance. Probably we won't use polymorphism, but it's a very powerful tool. That's why we introduced that. Okay. Any question first? We didn't set up the poll level yet because we have the chat. I will stop here for 3 minutes. Maybe we can chit chat. Then we will continue on the big O notation. Okay. The big O notation is the real thing. The real thing for our whole class. First, there's a question. What is the topic tested for quiz 1 on week 5? Anything from week 1 to 4, including week 5 tutorials. For assignment 1, the functions we need make, oh, sorry, I don't understand. Assignment 1, the functions we need make is it must not call each other or must call each other to simplify. So I don't understand the question. Maybe you want to ask me again? I don't quite understand the question. Yeah. Maybe you can also ask your tutor next Tuesday also. Yeah, because I don't understand the question. Yeah. Okay. Very good suggestion for the queues. Thinking if the linked list should be able to store where the tail is. That's called insert tail. Remember last time we talked about you can insert at the head, and okay, if you can insert tail, then you become a queue. Very clever. The assignment you are allowed to run submit multiple times without the finalized submission. You can run as many times as you want, but don't use it as a debugger. You should work your assignment with your own IDEs, then paste on it, okay? Is the child class like friend? No, different. Friend are friends. Friends cannot inherit your, if friends are communications. You have another entities as your friend that you can communicate, but not the parent-child so-called relationship. Is the friends is only for you to access something. Usually, 99% you don't want to use friends if you want to keep a very good programming style. Yeah. For example, the function is empty. Should other function use? Yeah, you should use other function. Yeah, you can use it if that's your question. For example, in your remove head, maybe you want to use your is empty function to check, which is a better way to do rather than write your own is empty functionality in the removal. That is a good programming practice. Think about that. Why is it good? Okay. So I'll end this because I want to create another recording. So I will just stop it here first.